time and geology.
Did you know that Earth is over 4.6 billion years old? That's an unimaginably long time. But how can we know so much about the Earth's history, even though we weren't there to witness it? This is where the concept of geologic time comes in. Today, we're going to explore how scientists trace the history of Earth, the techniques they use to date its rocks and fossils, and the most important events that have shaped the planet as we know it. Now, how do we know when all these things happened? To uncover Earth's history, geologists use two main dating techniques to date rocks and fossils, and these are relative dating and absolute dating. Relative dating tells us the sequence of events. It doesn't give the exact dates, but helps us understand the order in which events occurred. Some of the techniques are fluorine dating, serration, and stratigraphy. Absolute dating, on the other hand, measures the physical properties of an object itself, and use these measurements to calculate its age. Some of the techniques are radiocarbon dating, archaeomagnetic dating, potassium-argon, and argon-argon. So what's the difference between relative and absolute dating? Relative dating places events in sequence but doesn't give specific ages. Think of it as knowing the order of events, like knowing the Jurassic period came before the Cretaceous, but not just the exact years they happened. Absolute dating is like setting a clock. It gives us a precise ages, such as knowing a dinosaur fossil is 150 million years old, not just that it came after an earlier species. Both methods are actually essential in geology for understanding Earth's complex history.
Let's now turn to the geologic timescale. It provides a framework for understanding not just the past, but how life and the planet itself have evolved over billions of years. It divides Earth's history into eons, eras, periods, and epochs based on major geological and biological, the largest subdivision or interval in the geologic timescale. Eon often refers to a span of a billion years. We have era. It is the smaller subdivision of eons and the second longest portion of geological time. We have period. It is the basic unit of geological time during which a specific kind of rock system is released. We have epoch. It is the unit of geological time during which a rock series is deposited. It is also a subdivision of period. Provided here is an example of geologic timeline illustration, but it's kinda overwhelming to look at, right? Let's have a look to the key events of every subdivisions. We have Precambrian Eon. It is said to be 85% of Earth's history even before the current Phanerozoic Eon. It is also where rocks from this age were first studied. This super eon is composed of Hadean era, Archean era, and Proterozoic era. What happened in this era is the solidification of the Earth's continental and oceanic crust. It is also bombarded with meteorites on Earth, causing severe volcanic eruption. Next one is the Archean era. This is where evolution of Earth's first life forms, and Earth became warm during this era. And this time, most of the Earth was covered with water. Lastly, the Proterozoic era is the appearance of multi-celled animals and the gathering of land masses to form continents. This era also lasted almost half of the age of the Earth, and the continents started to drift away. After Precambrian, we have Phanerozoic Eon. It is also divided into three eras, which are the Cenozoic, Mesozoic, and Paleozoic era. The Cenozoic era is known as the age of mammals, and volcanic eruption took place on a large scale, forming colossal flows of lava and basalt. In Mesozoic era, it marked the breaking up of major land masses. It is also known as the age of dinosaurs. In Paleozoic era, life begins to flourish in the sea. It is also known as the age of invertebrates. And here are the periods under Paleozoic era. We have the Permian, Pennsylvanian, Mississippian, Devonian, Silurian, Ordovician, and Cambrian. In Mesozoic era, we have Cretaceous period, Jurassic period, and Triassic period. Cenozoic era has the following periods, which are the Holocene, Pleistocene, Miocene, Oligocene, Eocene, and Paleocene period.
Geologic time allows us to trace the Earth's long history from its violent beginnings to the present day. With dating techniques like relative and absolute dating, we can pinpoint the timing of important events. The geologic timescale helps organize the history into understandable chunks. By studying geologic time, we gain insights not only into our planet's past, but also clues about its future. The Earth has a rich history written in its rocks, and it's up to us to decode it. So what stories might the Earth still have left to tell?